Okay, let's take a look at question 20 in topic set 4. This question is a bit of a longer one. It says you have a compound called chloride chloride, and it gives you the formula there. And it says this is a drug that's used in the treatment of hypertension, and you take 1.28 grams of this drug and you destroy all the organic material in there and release all the chlorine. Okay, so basically what happens is, in terms of a picture, you have your drug, let's say in the solid form. You add some reaction to it so that when the reaction is completed, it says all the chlorine is released as chloride ion. So you still have some solid here that gets filtered out, and now you just have the solution containing the chloride ion, and then to this solution they add excess silver nitrate. They say as a result of that you obtain silver chloride for this much mass. The question is, what's the mass percent of the compound in the original drug? Now, just to explain to you a little bit what they're asking here, a drug, like a tablet, typically contains what we call the active ingredient and then plus some other stuff. These would be called binders, or they're basically things that make the drug digestible. For example, if you take it orally, you have to let that drug eventually get to your stomach, the active ingredient be released there. So you don't want to just give somebody the active ingredients. You would give the active ingredient along with some other stuff, and those other stuff are the ones that we don't really need, but it's part of making the drug work the way it should. And so the active ingredient in this case is that compound, the chloride chloride, and what we're trying to figure out is how much of the active ingredient is in the actual drug. So then the mass percent of the compound is just going to be calculated by taking the mass of the active ingredient, in this case, divided by the mass of the drug tablet. Okay. One of the things you need to interpret is that 1.28 grams that's given, that's the mass of the drug tablet. So what we have to figure out is the numerator. We don't know what that is, the mass of the compound. And we can do that by working backwards. So let's think about the information that's given to us. Basically, what they say is that the compound contains chlorine. The chlorine gets converted to chloride. The chloride somehow reacts and produces the silver chloride at the end. So we have to first start with that reaction, which is a reaction between silver nitrate and chloride. So let's think about what reaction might be possible there. Chloride is just chloride ion. Now the question, of course, is what happens when silver nitrate is in water? Well, that's a soluble salt, so it's going to break apart into silver ion and nitrate ion. You're not going to have a reaction between the anion and anion, so the reaction that's possible is between the cation and the anion. So you're going to form AgCl. The nitrate ion is just going to be a spectator in this case. Nothing's going to happen to it. Well, if you look at the solubility rules, you'll find that AgCl is a solid. This quantity right here is 0.104 grams. And so the question is, can we use that to figure out our original active ingredient? Well, from this reaction that we just have written down, we can use the stoichiometry between AgCl and chloride to figure out how much chloride ion we have, right? So that's fairly straightforward. We'll just say the number of moles of chloride is going to be the mass of AgCl, right, which is this guy right here. I'm going to convert that to number of moles, so we need molar mass of AgCl, 143.3 per mole. And then we're going to convert that to the number of moles of chloride by using the reaction. You can see in the reaction it's just a 1-to-1 stoichiometry between chloride and silver chloride, so we get our answer right here, and that is 7.2565 times 10 to the minus 4 moles. Now once we know the chloride, well, remember the chloride all comes originally from that active ingredient, which is this compound right here, right? So what we can do then is relate that using a mole-to-mole relationship through the chemical formula to figure out how much drug we originally have. So I'm going to do this. Mass of the active ingredient. Remember, the active ingredient is that chloride, right? So we're going to start with the number of moles of chloride. And then we're going to relate the chloride to the active ingredient. The formula is kind of complicated here. So C14H20Cl6N2. And we just have to figure out, well, how many chlorine is in this, which the chlorine then becomes chloride, right? So how many chlorine atoms are in here? Well, it's one of this produces 6. Okay, so it's 1 to 6 based on that formula. So we got the 1 to 6 relationship that gives us the number of moles of the active ingredient. And then we need to do one more step, which is to convert it to mass of the active ingredient. So for that, we're going to need the molar mass of this compound here, 429 grams per mole. And so once you do that, you're going to have your mass of active ingredient. And that ends up being 0.051889 grams. And so once we have that, remember the percent mass is given right here. So we need the mass of the compound, which is our active ingredient, and divided by the mass of the tablet. So the mass percent of our active ingredient is then the number we just calculated, divided by the original mass of the tablet, which is 1.28 grams, times 100%. And that ends up being 4.05%.